Okay, let's go over these. Quiet, please. We're going to go over these. Quiet. Okay, this way. So the number 27, which one of these does not have a range of all real numbers greater than or equal to 0? Another way of saying, which one does not have a range of y greater than or equal to 0? Okay, and it's D. Okay, now, you could put these in the calculator, and you should be able to make sense out of just looking at them in the calculator. If I put the, let's say I put the first one in, y equals clear, and let me get that. I'm going to do that later. Okay. So if I put in the square root of 4 minus x, and then I graph it, you know, you could see that it starts here and it goes to the left. Okay, that's domain. The range is it starts at x, on the x-axis and it goes up from there. That would be y greater than or equal to 0. Right, now you could do the same thing. This is an absolute value. Shape is a V. It clearly touches the x-axis and then goes back up again. This is, since it's 4th degree, it's going to look like a parabola like this. Touches 0, 0, goes back up again. But notice when if you put in log x, right? Clear. If I put in the logarithm of x, that means use this one on the front of the calculator. X. It's kind of hard to see what's going on there. Now you can zoom in with a zoom, right? Zoom, and 2 is for zoom in. You have to hit enter. And now you can definitely see what it's doing. I mean, it looks like what we've got on both sides of the board. You know, is it ever going to touch the y-axis? No, because that's an asymptote. You've got to know that, right? Because if you just depended on this, you might think that it actually touched it. It didn't touch that, right? So can you say that it does not have a range of y greater than or equal to 0? Sure, because these values here are all negative. That wouldn't be y greater than or equal to 0. Okay, but you honestly should just know that from these graphs. I mean, we know that a square root, when it's given to us, we assume it's greater than or equal to 0. An absolute value, greater than or equal to 0. You know, an even power, greater than or equal to 0. And then that one we would know, especially since it was the homework class, right, that it's all real numbers. So that's it. Okay, which one of these is in the same family as that? I mean, these three, again, we just did in the homework last night. Does that look like any of the graphs we just did in the homework? No, so it has to be this. But now you can put that in the calculator and just look at the graph. And does it look like it's probably in the same family? Right? Clear. Remember, how do we enter the fraction? Alpha, y equals 1. Now I'm going to put in the 3 over x minus 1. Right? And I hit zoom 6. So does that graph look like it might be in the same family as that graph? Same basic shape, 2 branches. Yes. I mean, do you remember what do you call that function? Inverse variation, right? And it's been shifted how? 1 to the right, because inside the function there's a minus 1. And that's what it looks like here. It looks like the asymptote is probably at x equals 1. Okay, that was the 29. Okay, what is the equation for the horizontal asymptote of the graph? Okay, what kind of a function is it? Exponential, growth or decay? Growth, because 6 is greater than 1. Okay. 6 is greater than 1. So we would expect an exponential graph. The exponential growth would look like that. And then we have an asymptote on the x-axis, which has got an equation of y equals 0. Okay. What is the minus 5 inside the function doing to that graph? It moves this whole graph to the right 5. Does that move the asymptote? No. A horizontal line is still in the same place. Okay, how about the -4 after the function? Down 4. Does that move the asymptote? Yes. So where is the asymptote now? Y equals -4. Okay, the whole graph moves down. And this is almost the same thing. Which one of these looks like it's this graph? And again, just looking at the shape of the graph, it looks like exponential growth, and all 4 of these are exponential growth. What does it look like the shift is? It's down 4, right? It's not down 3. Don't look at that 3, because remember, before you shift the graph, it would have had a y-intercept here. Come on. It would have had a y-intercept there. That's down 4. It would have had an asymptote here. Now it looks like it has an asymptote here. So that would be this one. Okay, if we were just looking at the normal logarithm, hasn't been transformed at all, y equals log of 2x. Oh, sorry, I just said I wasn't going to do that. Log of x, right? That would look like this. Head of an asymptote here. Okay, if you make that into a 2x, does that move it left, right, up, or down? It doesn't really change anything about this graph. Well, it changes a little bit, but still, it's not being shifted up, down, left, or right. Now, looking at this graph, how many x-intercepts and how many y-intercepts does it have? How many x-intercepts? 1 right there. And how many y-intercepts? It can never touch that line, so it's still 0. Now, you could confirm by putting it in the calculator and look at the graph. The logarithm, that means that logarithm, 2x. Graph. Again, it's hard to see what's going on there. You can zoom in a little bit. Zoom to, and you could definitely see it still has the x-intercept. There's 1. But again, it looks like it's approaching the y-axis like an asymptote. So it's never touching that. So the right answer would have been this. Okay, so this one, logarithm, before it's been shifted, has a graph that looks like that. Right, it goes through 1. And what is the equation of that asymptote? X equals 0. I mean, you have to be straight. That when you name a vertical line, it's x equals a constant. If it's a horizontal line, it's y equals a constant. If you don't understand that, don't take pre-cal next year, okay? It's silly. You got to know that much. You've been taught that for years, right? So years and years and years. Now, which one of these here is going to shift that graph and the asymptote? Does it shift the graph to go up 15? Does it shift the asymptote if we move this whole graph up 15? No. Does it shift the asymptote if I move the whole graph right 16? Yes. Now where's the asymptote? X equals 16. Okay. You need a little knowledge on these. If you're just sitting there playing with it for forever on the cat, I mean, you put this one in, what did you see? If you didn't see it, right? Because it's so far off the graph that you couldn't even see where it was. And it was never intended that you put this in the calculator, that you just say, oh, it was at x equals 0, now it should be at x equals 16. Done. It should take you 5 seconds to answer that question. Okay. Now, one that we didn't do was the number 30, which is another logarithm. And this one says, which of these is a 0 of the function? right? What do we mean by a zero of a function? Makes f of x equal 0, makes the y equal 0. So it's the x value that will make this equal to 0. Okay, well, how could you tell? I mean, you could plug in, I guess. I mean, you could just plug in 7 halves. 4 times 7 halves would be 28 halves. That would be 14. The log of 13 equals 0. You could put it in the calculator. It doesn't work. I mean, you could do it that way. What I would say is we do this more with polynomials than we've done with logarithms. But normally the way you find a 0 is you put it in the calculator. And what do you look for in the calculator? Where it crosses the x-axis. Right? So let me clear this. Log of 4x minus 1. And graph it at a normal zoom, zoom 6. And you know, it's very hard to see what's going on there. So I'm going to zoom in just to see a little more. Okay, so that is the x-intercept. That is the 0. And could you estimate it by looking at the graph? I mean, each one of these tick marks is 1, so what do you think that looks like? It looks like it's 1/2, and that is actually one of our options. So you could try it. Put in a 1/2 there. 4 times a half is 2. 2 minus 1 is 1, right? What is the log of 1? 0. So that is right. Now, you could also use your calculator. It will find zeros for you. Do you know where to find that? Or do you remember? Because we did do this some. It's on the trace, where it goes second trace. I mean, more recently, we've been doing the intersecting, right? But you could also do 0, number 2. And it's going to ask you questions, left bound, right bound, guess. So if your 0 is here by left bound, they mean put in an x value which is to the left of the 0. And you can do that by just entering the value, or you could use the arrow key until you see the cursor. There we go. See, since this graph is going down and to the left, when it's below the x-axis, it's a little bit to the left. So if you're okay with that being your left bound, you say, okay. And then for the right bound, you could use the arrow key. Make it go above. There's got to be a 0 in between there. And it's clearly to the right. Okay. And then if you're happy with where you put those two, left bound and right bound, you hit enter. And it tells you that 0 is 0.5. But that will find zeros for any kind of function. As long as it's on the graph, on the screen, it'll find it. We'll do more with zeros next class. Okay, today we're going to do absolute value inequalities. Now there's 2 kinds of these, 1 variable and 2 variable. And we've actually did a lot of this throughout the year, but we haven't done a lot of this. And really the only way to do something like this is with the calculator. That's not quite true, but we generally do this with the calculator. I think that you need to remember how we actually do these without the calculator, but then what's different about using them with the calculator. So these are 1 variable inequalities because they're just an x, right? These are 2 variables because there's an x and a y, right? So let's remind ourselves, how do we do this? What's the first step to solve an absolute value equation or inequality? Isolate, right? But these, it's already done. So you don't have to do anything to isolate these absolute values. How do you rewrite this absolute value without the absolute value symbols, right? How do you break it down? No. It's the 3-part inequality, right? You would write -2 is less than x minus 1 is less than 2. And then you solve for the x in the middle, right? What do I have to do to isolate the x in the middle? Add 1, right? +1, +1, +1. So this is -1 is less than x is less than 3. Right? Now if I graphed it, we would have -1 on the left, +3 on the right. Would I use open or closed circles? Open because, yeah, because it's not or equal. That means -1 and 3 are not part of the solution. So you have to use open circles. And then where does the shading go? Between, right? The x is in between. The x is the shading, right? And that's in between -1 on the left, +3 on the right. So the shading is here. Okay, how do you break down the absolute value greater than? This is the two-part inequalities, right? What's the first one? Less than or equal to -2. And those are tied together with the or. That's a compound inequality. Now solve them both. Add 1. And here's your number line. -1 is on this side. 3 is on this side. Whoops. That was too fast. Should I have open or closed circle this time? Closed because it's or equal to. -1 and 3 solve this, right? So there and there. Now, if it's x greater than or equal to 3, where do I put the shading? It's greater than 3. So where on the number line is greater than 3? To the right. Okay, and how about x less than or equal to -1? Okay, here's the -1. It's less than or equal to. Less than on the number line is left. Right. Now, how do you do that in the calculator? Clear. Let's do this one first. Right? Remember, it's a one variable inequality. There is no y, but we're putting it on the line y equals. So we really don't care what goes on with the y and to the left of that. We just want to put that inequality to the right of the equal sign. Right? Where do I find the absolute value? Alpha window, math num1, what is it, second 0. There's a lot of different ways to get there. Alpha window 1. Okay, now put in the x minus 1. And then we're out there, we need the less than. Where do we find all the inequality symbols? Second math. Second math. There they all are. Pick out the one you want. Looks like it's 5. And that is less than 2. Right, so that look right? Hit graph. Let me zoom 6 to get us back to normal. So it looks like it's going from -1 on the left to +3 on the right. Now you won't be able to tell just by looking at that whether it includes its open or closed circle, but you should know because you're looking at that, and it's definitely going to be open circle. But it's telling you where you should go from -1 to 3. Okay. Now let's do the other one. Okay, this time it's greater than or equal to, so all I need to do is change that right there. Second math, and that looks like number 4. Does that look right? Absolute value of x minus 1 is greater than or equal to 2. Graph. So it looks like it starts at -1 and goes to the left, starts at 3 and goes to the right, which is pretty much what our graph looks like right there. You know, again, you would have to add the includes -1, includes 3 part because you see that it's or equal to. Okay. Now, if it's a 2-part inequality like these, you do the inequality part slightly differently. Now, before I do that, the way you graph a 2-variable inequality is first you graph the line that you would get if that were an equality, an equation. Right? And what is the shape of that graph? Absolute value. It's a V. But it's shifted how? -1 inside means right 1 plus 2 outside means up 2. So you would shift a V, right 1, up 2, right? Now, if it's a or equal to, you use a solid line. If it's not or equal to, you use a dashed line. And because it says less than for Y means below. So shade here. This one would have the same graph. The V would be in the same spot. Now it's a solid line because it's or equal to. And because it's greater than, Y greater than, that means here. Now your calculator will do that for you too. Go to the Y equals, right? Clear. Let's say we're doing this one right there. Y is less than X. Let's see, is that the right one to do? Yeah, we'll do it. Y is less than the absolute value of X minus 1 plus 2. So now the X minus 1 plus 2 here. Alpha, window, 1. X minus 1. Plus 2. Okay, now in order to get the shading in there, you need to move the cursor all the way into the left margin, right there. So scroll all the way over. See that? And now hit enter. Okay, if we graph it, it would use a fat line now. If I hit enter again, I get the upper right triangle. That means greater than, right? We want the less than, so we hit enter one more time. That lower left triangle means the shading is below. So it will do all of that for you. Right? And the only, if I wanted to change to a greater than, then you hit one more time. No, sorry. We already did that. There. Too fast. Right. That's the greater than, and then the next one, greater than. That's the less than. When you let the calculator do it, the only thing you really can't see is you can't see the dashed versus solid, right? You didn't tell it that. You have to know that part. Okay, so do these 15 and 18. It's one of each. One variable and one two variable. Did you finish already? Let me see this. Justo. And that's right. Is that greater than? So which one does that look like? Okay. Okay. What's the next one? Did you get that one? Which one is it? How'd you get that? Okay, let me see. So there's the V. Well, how do you put the shading in there? It's greater than. So you have to go into the go up there, go into the margin, and I enter. That's greater than. Now hit graph. Okay. Remember, that is a 3-part inequality. If you go like that, there's no absolute value pointers anymore.
Left 1 is right there. Right there. Yes, it is.
It's not left 1.
What do you mean?
It's left 1/2.
Where? Oh.
Because it's a 2x plus 1.
Exactly. I know what I'm talking about.
But they didn't try to fool you with that anyways, right? I mean, it is definitely to the left and it's down 3. So it had to be one of these two. And it's greater than, so it's that one. Did you get the other one?
What other one? 18? Yeah, I did.
Let me see. You just solved it?
Yeah.
Most of these things, if you just know the math, you do them way faster than all the calculators fiddling around. How we doing? Done? Did you get them? Okay. What was the right answer? A. You know, this one is a little complicated because it's got 2x plus 1 inside. It's not just like x plus 1. If it was x plus 1, what kind of a shift would that have been? Left 1, right? But because it's 2x plus 1, then really it would be x equals negative 1/2 is the shift, right? Because that's the 0. 2 times negative 1/2 is negative 1 plus 1 is 0. So that is actually a shift. You can see it's in between the 0 and the negative 1. But they didn't try to trick you on that part of it anyways. I mean, it's clearly shifted down 3. And neither one of these two is shifted down 3. So it had to be this one or this one. And then it was greater than or equal to, which meant that one right there. And the 18, what did you say? It was B. Again, I'm not going to do that one with the calculator. Just turn it into a 3-part inequality. Subtract 4. Done. What do you say? Easy? Okay. So the homework is going to be this. This is going back to the quadratic chapter and factoring. So write it down, and then we're going to take a quiz in a few minutes. So if you want to look in your package right now at number 1, 2, 3, 4, and 24, those are what the quiz questions are like, right? Look at those. You should have been writing notes along the way to remind you how you could solve a problem like that.